Hello guys, welcome to Java session. Today's topic is nested type declarations. In today's session, we will discuss about introduction, static member types, non-static member types, local classes, and anonymous classes. Nested type declaration introduction. A class declared within another type declaration is called nested classes. Like means class within a class. Similarly, an interface or an enum type that is declared within another type declaration is called nested interface or nested enum type respectively. Okay, there are four categories of nested classes. One of the nested enum types and one of them are nested interfaces defined by the context. These nested types declared as follows. Okay, static member classes, enums and interfaces, non-static member classes, local classes, and anonymous classes. The last three categories are collectively known as inner classes. Instance of these inner classes can be associated with instance of enclosing class. We will discuss about these inner classes in detail in next slide. Static member types. A static member class, enum type or interface comprises the same declaration those allowed in ordinary top level classes. A static member class must be declared explicitly with the keyword static. As a static member of enclosing type, nested interfaces are considered as implicitly static. Means if we have class list pool here, if you look at this sample code snippet, public class list pool. This is our top level class and it has one static inner class, public static class my linked list. Okay, within the static member class, whatever we define, those methods are static member interface. See here, private interface ilink. Okay, this is a static interface. So within a class we have one more static interface, and also we have one more static member class, public static class bi node implements iblink, and this iblink is outside of this my linked list class. Interface iblink extends my linked list dot ilink. So we will see how this works, like class within a class, and these classes are static, right? And how we will create these static classes, and how we can execute these interfaces or classes. If we look at this list pool class, see here, this is our top level class and it has one instance method message in list pool, and here we are printing system.out.println. This is list pool object. Okay, within this list pool class we have static class my linked list. So within a list pool class we have static member class. In this static member class we have one variable, two variables. One is a static variable, private static integer maximum number of lists 100, and also we have instance variable private int current number of lists, and one method public static void message in linked list system out println. This is in my linked list class. Okay, along with this message method we have one interface within my linked list a static class. This is called static member interface. So private interface ilink integer. See here, maximum number of nodes, this is a constant. Okay, within interface we can declare constants, which we discussed in earlier sessions. And also we have so first of all, this is top level class. In top level class, we have one static class, and in static we have one interface. And within a static class, we have one more static class, public static class bi node implements ilink. Okay, and it is private integer max equals to maximum number of nodes. And here public void message in node integer. So here we have one method maximum list max nodes, and here we are calling message in linked list. So if we look at these variables, okay, and methods, we have one instance method in list pool, and in static inner class we have one static variable and one instance variable and one static method. Okay, and if we want to access any variables or methods of its enclosing class, those methods or variables should be static. See here, we have current number of lists, which is instance variable, right? So what I'll do here, I wanted to declare this integer current list equals to current number of lists. So this is this current number of lists is my linked list instance variable, which is, so it's enclosing context, right? Bi nodes enclosing context is my linked list. So here we are not able to access instance variables of enclosing context. So only we can, these static inner classes can access static variables or methods of its enclosing context. So if you look at here, cannot make a static reference to the non-static field current number of lists. So we cannot access. In the same way, see here, message in list pool, which is also a instance method. It is not a non static method. So what I'll uncomment this one. See here, cannot make a static reference to the non-static method message in list pool from the type list pool. Okay. So if you look at here, message in linked list is static method. So static inner classes or interfaces can use, I can call their static member types of its enclosing context. Now public static void main in BI node, what we did, message in linked list of its my linked list method. Okay. So if you look at this class, see how many classes we have created. This is our top level class. Okay, class 1. Under list pool class we have my linked list class. Okay, and in my linked list class we have one interface called ilink and also bi node. So list pool is the top class, first class, and within the list pool we have my linked list, second class. In my linked list we have 2.1 interface ilink and bi node 2.2. So the third level is um, uh, ilink interface and bi node. So like this we can create n number of classes within a classes. This is called static classes, and these of type static member types. Okay. So how these objects will be created? So when we create these classes like this, how the class files will be created? Let me show you how the class files will be created. See here, we have list pool, right? This is the main top level class. In list pool class, we have list pool my linked list dot class. Okay, and in my linked list we have two. One is ilink interface, and another one is bi node class. Okay, and I have created one more interface called iblink. So like this. So and this is separated by C, and the file name is separated with a dollar symbol. So class name, top level class, uh, dollar, and the inner class name. Like this, we have created four classes within the classes. So these four class files got created. Okay, and how the objects get created. So if and how we need to refer, how we need to invoke these objects. If you look at here, my public class my bi link list implements list pool dot I bi link. Okay, list pool dot the first top level class dot static inner class my linked list dot bi node. So like this, class name dot the second class name dot the third class name, and object reference new list pool dot my linked list dot bi node. Like this we can create objects. Okay. So static member class or interface is very much like any other top level class or interface. These static member classes or interfaces belongs to a class, not the instance of a class. A static member class can be instantiated without any reference to the instance of its enclosing context. So like we need not to create an object of its enclosing class. Directly we can use its enclosing context dot that particular object. Okay, that particular class. So I have already shown you like how the files got created, right? List pool, iblink, blink, linked list, and these things. Okay, we will run this Java program and see how the results come. Okay, so run as. Here in top level class we don't have main method, and we have a main method in class bi node. So for that, what we need to do is click on run configurations. So we need to find out where exactly that class is there. Okay, so what we can do, we'll create new. So bi node. Okay, and run. See, this is my linked list class. So if you look at here, public static void main message in linked list. So this message in linked list, this is my linked list class. Okay, so this is how we can create objects. And see how we can create objects here. List pool top level class dot my linked list static first inner class dot bi node. Bi node is another static class. Okay, is equals to, so here list pool dot first class name dot static, as this is a static class, just you can use the class reference, so you need not to create an object. My linked list dot bi node. Okay, and node object, here node object dot message in node. Node obj static. Okay, yeah, because this is not a static method, so here we are not able to access because this is not a static variable, so that's why we are not able to get this particular method name. Okay, and we'll go back to the next slide. So accessing members in enclosing context. So if you look at here, list pool and messages in list pool class we have my linked list, and it has maximum number of lists, create number of lists, and node, and this node class and iLink interface within the my link list class. Okay, so like this the class hierarchy is, and how these classes are accessing its enclosing context variables. Next, non-static member classes. Non-static member classes are the inner classes that are defined without the keyword static as members of its enclosing class or interface. We need to, when we write these non-static member classes, we need to keep this in mind, that an instance of a non-static member class can only exist with an instance of its enclosing class. So in earlier static member classes, we haven't created any object of its enclosing class, whereas in non-static member classes we have to use its enclosing class instance. Okay, and code in a non-static member class can directly refer to any member of its enclosing class or interface, or including private members. No fully qualified reference is required. Okay, and code in a non-static member class can directly access to the any member of its enclosing class or interface, including private members. Since a non-static member class is a member of its enclosing class, it can have any access specifier like public, default, protected, and private. A typical application of non-static member class is implementing data structures like linked list, okay, queues. So these data structures we can stacks we can implement using this non-static member classes. Okay. A special form of new operator is used to instantiate non-static member class. So as we already said, like it's enclosing class object. So enclosing object reference dot new non-static member class. So in static member class, what we did, just class name. Okay. In previous this one, list pool dot my linked list dot bi node, whereas here we need to create an object of its enclosing class dot new of this inner class non-static member class. Okay, this enclosing object reference in the object certain expression evaluates to an instance of enclosing class in which the designated non-static member class is defined. Okay, let me give an example on a non-static member class. Yeah, in the previous example, we missed that message in Node, right? We missed the method in the main, the statements in the method. So that was the reason we were not able to find out this message in Node. So I have put these statements in the main method. Okay, so now if you look at this one, list pool dot my link list node object my bi node, and here node object dot message in node, and if you run this as Java application, this is my linked list class. So earlier what we were trying to do, just I have created a reference and trying to access, so it was not there in the method, so that was the reason we were not able to access. Okay, now we will go to the non-static member classes. Here, this is our top level class my linked list, and it has one instance variable private string message linked list objects. Okay, and it has inner class non-static class, non-static class, which has here, see, here in non-static inner classes can contain only non-static variables and constants only. See, if I try to create a static variable here, static integer maximum number of nodes 100, see here, the field maximum number of nodes cannot be declared static in a non-static inner type. So we cannot write static types within a non-static inner type classes. Okay, so this is not allowed. That's what we discussed few minutes back. And here constants can declared in non-static inner types private string node info and private node next, and also public node one constructor string node info node next. So these are the two variables. Okay, these are the two instance variables, and these instance variables are assigned with the passing parameters. Okay, node info and next, and we have written here two string method just printing the statement. Okay, public string make instance, and also we have one public method node make instance info and next. And how to create these objects, let me show you the client of this one. So my linked list equals to new my linked list, and my linked list dot node, so node is inner class, right? This is node is inner class dot node 1 list. So first what we did, we have to create a object, so object of its enclosing class dot new or else make instance. So just we are calling its method make instance. Okay, make instance, we are passing the parameter string and object null. Okay, so system.out.println node 1. And also if you look at here my linked list dot node 2, and we have what this list object reference dot new node. So inner classes can be created using new operator. Okay, new node of node to null. So this way either we can use their variables methods or their object. Okay, object creation like dot new inner classes, whereas in static member types we cannot we need not to use this enclosing context objects, just directly we can call their class names. Okay, if you look at here, mylinkedlist.node, new mylinkedlist.node. So directly we cannot call the inner classes objects. So we cannot create like this. So in static member types we used to do like that, whereas here in non-static inner member classes we have to create object first, then only we can invoke their child class objects. Run as Java application. See here, linked list objects in node 100, node 200. Like this we can print or we can create objects of non-static member classes. Next, local classes. A local class is an inner class that is defined in a block. This could be a method body, a constructor body, or a local block, or static initializer, or instance initializer. Blocks in a non-static context have this reference variable which refers to an instance of class containing the block. So these classes can create within a method body or constructor body or local block, static initializer or instance initializer. So these classes can be created anywhere, and these local classes cannot have static members. So we cannot have static members within the local classes as they cannot provide class specific services. So only we can use instance variables, not static members. Okay, and local classes cannot have any accessibility modifier, so we cannot use any accessibility modifier. So clients outside the scope of local classes cannot instantiate the class directly because such classes are local. So within the method, so those classes are within a method, within a block. So these classes cannot be, we cannot create an object of these classes from outside the class. So a local class can be instantiated in the block which it is defined like a local variable. A local class must be declared before being used in the block. A method can return the instance of any local class it declares. See here, we have this painted class which is having shape create circle. Okay, this circle is extending the shape class which is outside this painter, and shape implements the drawable interface. Okay, and also painter class is having static drawable create map which is static variable. Okay, so we will see like how local classes works. So we'll write a sample program and how it works. Okay, so we have one painter.java file, okay, in which one interface iDrawable which has draw method, and also class shape which is implementing iDrawable, public void draw. So we implemented the draw method, public void draw system.println drawing a shape, and this is our top level class painter, and which has create circle method. Okay, and this is one method, public shape create circle, find final double radius non-static method which has class circle extend shape. So this is called a non-static local class because this class is defined within a non-static method, and it has public void draw system.println drawing a circle of radius. Okay, see here, this field A cannot be declared static in a non-static inner type. See, so within a local class we cannot declare a static variables. Okay, here, and this circle is having a draw method system.out.println return new circle. Okay, this is the object, and also public static iDrawable static method. Okay, here create map class map implements iDrawable. So can we define here static? No. We have already discussed that these static variables cannot be used in local classes. Okay. And it has public void draw system out drawing a map. And here also we are. So classes defined within a method or within a block static within static initializers or instance initializers. So wherever we define these classes, those classes is called as local classes. And how we'll create an object of these local classes? See here, this is drawable interface. Here, top level class new painter dot create circle. So this is our method, and this circle internally creates an object of class circle and returns the draw method. So we implemented draw method in circle, right? Here circle is having draw method. So when we create painter implements dot draw means it will not drawing a shape. So it uses drawing a circle of radius. Okay, and also dot create map. So we have, this is non-static method create circle. In the same way, create static method also we can call. And also we need not to create an object of painter also directly, painter dot create map, because it is a static method. So we have object of static, so new painter dot create map also we can call, or painter dot create map. So if you look at here, run as Java application. So drawing a circle of radius 5.0, drawing a map, drawing a map. So like this we can create an object and call those appropriate methods. Okay. Next one, anonymous classes. Classes are usually first defined and then instantiated using the new operator, right? So generally what we have seen so far, classes first we define, then we'll instantiate using new operator. Whereas anonymous classes combine the process of definition and instantiation into a single step. So this defining a class and creating an object, both takes place in single step. So those kind of classes we call it as anonymous classes. Anonymous classes are defined at the location they have instantiated using the additional syntax with the new operator. As these classes do not have name, an instance of a class can only be created together with the definition. So if you look at here, public painter, class painter, shape, create shape. So earlier, if you remember, in local classes what we did, class circle extend shape, but here directly we are calling return new shape. Okay, so public void draw method. So here we are not declaring the class name, so just directly creating an object and implementing draw method. And in the same way, iDrawable, so create a map here there in the earlier local classes concept, but here if you look at here, return new draw iDrawable public void draw. So like this what we can do, we can create uh, objects on the fly. So we are defining and creating an objects. So this is known as anonymous classes. We will write an example on this anonymous classes and see how it works. Okay, so here interface iDrawable void draw method, shape implements iDrawable, drawing a shape, painted, create shape, return new shape. So here we are not declaring class name, okay, just extending the shape class. And drawing a new shape, iDrawable, drawing a new iDrawable. And same, create shape, create iDrawable, create drawable. And just we are calling their methods. Drawing a new shape. So this is how we can create class and instantiate an object, okay, on the fly. So if we look at this table, these top level classes or enum or interfaces package level declaration context, whereas static members as a member of top level type or nested static type, non-static members non-static member of enclosing type, local classes in block within a non-static context, in block with static context. Anonymous classes, so we have a static context as a non-static context, whereas non-static only under the non-static, whereas static members top level type or nested static type. And access specifies public or default. Here static classes we can use all, whereas local we cannot use any access specifier, none. See here. And enclosing instance So we don't use object, right, in top level class directly, no. And even static member also, we never use enclosed objects. Whereas non-static member classes, yes, local classes, we have to use enclosing class object. Okay, and local classes as. Whereas if you use static, we need not to create object of its enclosing context, like that. See, static members in enclosing, all members in the enclosing, all members, local classes, and final local variables we can use. Final local variables can use, and declaration type. So this is what we discussed, and we represented in the form of this table. Okay. If you have any questions on today's session, please mail us at info@bicourses.com. We are happy to answer your queries and questions. Thank you so much.